afternoon, ladies and gentlemen. Good morning, good evening, wherever you are, any part of this world. Today we'll be discussing about tensor analysis. Let me quickly share my screen. What are the things that govern what are the things we'll be talking about? Like I told you, tensor analysis. We will just look at some of the definitions one after the other and some of the law that governs it. And it will also help us in solving coordinate transformation. So when we are talking about transformation, what are the things do we need to know about transformation? So let's x1 raised to s1 raised to s2 to s raised to power n and x bar 1, s bar 2 is a notation. They can use anything to denote in tensor raised to power n. Let me use this capital N2. B the coordinates of a point in two different frames of reference. So suppose there exists an independent relation between the coordinates of the two systems having the form, suppose there exists an independent relation between the coordinates. Can you see my screen?
Yes, sir.
Of the two systems having the form, excuse me, having the form x, that's it, x bar 1 equals to x bar 1 into s1, s2 to sn s bar 2 equals to s bar 2 into x1, s2 to sn. So if you continue that way in the general form, what are we going to have? We have x bar capital N equals to x bar capital N into x1, s2 to sn. We can briefly indicate that S by K is the same thing as S by K into X1, S2, S capital N, where K is the same thing as 1, 2 to N. You can see how the transformation is being occurred one after the other, one after the other. We call it, if we are asked to define coordinate transformation, this is just a simple way of defining it. Coordinate transformation. Under the coordinate transformation, you define it this way, and from there, you can move on. But in case you are asked to now write this summation convention, the summation convention will be, let's say, A1, the expression can be in this form, A1 x1 plus A2 s2 plus A capital N S capital N. We can use the short notation by calling it summation of j equals to 1 to n, that is aj and s raised to power j. You can see, we can write it in this form. That is, when your j is equals to 1, you have a1 x1. Are we together?
Yes, sir.
Okay, you have a1 x1. So this case, we continue to use it, especially this expression in Tensor. That is why in Tensor, we clearly, instead of using j index j, we can use another letter, say p or some of q. They can write it in this way. They can say ap sp. It's still the same thing. It's just, we call it a dummy index or umbrella, from the word umbrella index. So all these things are just a kind of definitions that will be necessary. But now let's look at when you have a contravariance. Contravariance and covariance. Covariant vectors. If n quantity a1, a2, comma an in a coordinate system, x1, s2, sn are related to n. are related to n. Other quantity a by 1, a by 2, a by 3, and so on. In another system, in another coordinate system, we have also x by 1, x by 2, x by n. By transformation equation, we have a by p equals to the summation of q equals to 1 raised to power n. So we have the x bar p, the sq. Don't forget, multiply by aq, where your p equals to 1, 2 to n. And which the convention adopted can simply be written as a by p equals to the partial derivative of x by p over partial derivative of x by q. Everything multiplied by the matrix of A. So this is called the component of a contravariance vector or covariance tensor of the first rank or first order. It depends on what area you are working on. So, but for covariance, it's also similar, but they're different. So another way of for the covariance, we have this one, A by P subscript P. You look at the difference, equals to summation of Q equals to 1 to N, the SQ, the S bar P, A subscript P, sorry, A subscript Q, A subscript Q, or we have A bar subscript P equals to the SQ over the S bar P AQ. So we call this one a component of a covariant component or the first or covariant tensor of the first order. So they can also ask us, what about when you have another way of writing it in the second rank? What about this is the first rank? Don't forget, first rank. In the second rank, what happened? Let's look at it. If n raised to power 2, then our quantity will be AQS in a coordinate system a coordinate system oh, okay, x1, s2, s to the power n are related to n2 other quantity. So when you have a bar PR in another coordinate system of x bar 1, x bar 2, then x bar n. By the transformation equation, we have this. We have the following. We have a bar PR, raised to power PR is equivalent to summation x equals to 1 to n, summation q equals to 1 to n. So for us to write this one, we have the x bar, don't forget, raised to power p over the x raised to power x. Same thing, the s bar, we are trying to split those representation raised to power r over the s raised to power s. This is raised to power q, since we are working with p. So everything multiplied by qs where your p comma r is the same thing as 1, 2 to n. So these are the things they will ask us to do. And when you have a PR equals to the S bar P over the SQ, then the bar R over the S A multiplied by Q subscript A Q S. So this is where you have two second rank. This definition, we use it at the second rank. That's why we call it second rank. But there's something very important that we need to also take note. But in the situation whereby you have a definition of AR, A bar P and R equals to the SQ over the S bar P, the S bar R over the X bar R multiplied by A raised to the power QS. So these are the definitions they will also be asking us. But at what point do we have our chronicle data can be written as delta JK is defined by delta J P equals to 0 if J is not equal to K, then 1 if J is equals to K. So what do I mean by this? Remember 3 by 3 matrix. Let's say matrix M is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. So this thing holds. If I want to translate it from here now, so it will give me this 1 0 0 0 1 0 0 0 1, because it says, the law says J equals to K. Anytime J equals to K, is always equals to. Are you getting it?
Yes, sir.
So take note of that. But tensor of rank greater than 2, how do we express that? When you have a tensor greater than 2, if it's greater than 2, for example, when e.g., when you have A, Q, S, T, K, L, we are having, how many rank do we have now?
This will be the third rank. We've done a rank of first rank, done second rank, and if it's greater than 2, this is going to be the third rank.
Yes, it's 5. We have 5. That's the meaning. The components of a mixed tensor of rank 5. Are you getting it now? So how do we write something like this? It's very simple. We have our A bar, P, R, M, I, J will be the X bar, P, the Q, the S, Q. The SQ dot the X bar R, the SS, then the X bar M. Are you seeing what I'm saying? Because we are taking the alphabet one after the other. those directions, we're taking them one after the other. By T. Then the S by K is equals to I. And the last one, the XL is the X by J. So you notice that anyone with up that is raised to power, we don't put the bar there. We rather put the bar, we put the bar for the one raised to power, while the subscript, we put the bar down. Please take note of that. Everything now multiplied by QST KL. QST KL. Please take notes of that. Then, like you said, go and read about tensor field, symmetry, and skew symmetry. They are also there. Then addition, subtraction, or multiplication, they are also there. Please make sure you learn them. Any questions so far?
None, sir, for now.
Okay. But the definition, does it really help? Does it matter?
Yeah, the only few definitions actually, but this one actually makes me understand the transformation better because I tried solving one of the past questions.
Okay.
So I get it very well now.
Okay, that's fine. So that's why if you don't know the elementary, it is always difficult to cope when you get to the main thing. For example, if you look at the sum now, how do we do the sum? Part of the operation we're using addition. For the addition now, if you have A raised to power MP Q and B raised to power MP Q. Both are tensors and they want you to add them together. It's good. Addition will now be implied as C MP Q equals to AMP Q plus BMP Q. So you can see the addition. Then if I have that addition, for subtraction, if I have A MP Q and I have B MP Q, the final answer will be D MP DMP Q is equals to AMP Q minus BMP Q. For the multiplication too, outer multiplication, you have For the same example, you have AP, R, Q, and BMS is equals to C, PRM, QS. Do you understand what they did here?
Yes, sir. Yes, sir.
So what we are saying is, which implies equals to APRQ. Don't put dot so that they won't think it's dot you are talking about. Multiply by BMS. So they match everything together from the law of indices in that case. So it just use something similar, but it's a bit different, not law of indices. For this reason, division of tensor is not always possible. Please take note. Division of it is not always possible. Are we together now? And I've already explained the matrix for you, the way the matrix works. Then when you have, let's look at this definition also for the matrix. For the matrix, if A is equals to A PQ and B is equals to BP, are matrix having the same order m by n, then number one, A equals to B if and only if A PQ is equals to B PQ. Number two, the sum S and difference, the difference D, are the matrix defined by S equals to A plus B, which is the same thing as A PQ plus B PQ. Then for the D equals to A minus B, that one will be A BQ
Minus BPQ.
eh?
No, sir. No, sir. Please continue, sir.
Minus B. Yes, you are saying it. That's why I said eh.
Okay, sir. I didn't know you heard me, sir.
I heard you. Oh. So in this case now, when you now have the product, don't forget it's not ordinary product of P AB, of matrix AB, is defined when the number of column and the number n of column in A is equal to number of row in B. That is, the number of columns is equivalent to number of row. That is, P equals to AB, the same thing as A PQ and B PQ is equals to A PR and B RQ. So then where we cannot write the summation here, where A PR B RQ is the same thing as summation of R equals to 1 to N A PR B RQ by the summation convention. The matrix whose product is defined are called conformable. They are called conformable. So in general, multiplication of matrix is not commutative. When they say something is not commutative, that is AB is not equals to BA. That is AB is not equals to BA. Not commutative. Not commutative. However, associativity law for multiplication of matrix hold. That is, let's say this one does not hold, but let's look at this. A, B, C is the same thing as A, B, ABC, provided the matrices are conformable. And you know, for the matrix to be conformable, it must obey the law that says the number of rows must equal to the number of columns, right?
Yes, sir.
So that is when it's going to happen. And it's also distributive law holds. The distributive law holds when you have A, B plus C equals to AB plus AC. That is A plus B into C, which is the same thing as AC plus BC. So these are the little things that I think you also need to know and be able to solve. Then also they can ask you to determine for the determinant of a square matrix. Don't forget you have a matrix of A to B, A PQ in this form, and is denoted by A, determinant of A, which is determinant A, APQ, or determinant APQ if P equals to AB. then the magnitude of P is equals to magnitude of A, magnitude of B. So it's easier for us to solve by this way. Same thing happened to inverse of a matrix. I believe you still remember from the elementary mathematics, the inverse, which is same thing as A multiplied by this, and it will give you identity. So these are the laws, simple things that you need to do and add to what you've learned so far. So then there is I believe you can state a Christopher symbol. Christopher law of transformation. Do I need to state it?
It's in the textbook. I tried reading. I only read through it. I've not memorized it actually.
Okay. It's also in the textbook. You can actually do that. And in case you have any other question, let me know. I think majority of what they ask you guys is definition, right?
Yes, definition and the proving that we just did up at the upper part.
They can ask you this chronicle question also. They do ask. If they ask you that, okay, evaluate A, the chronicle of P, Q, A, Q, R, S, B. The chronicle P, Q, chronicle Q, R. So how do we solve this? Since, that's how you start. Since chronicle P, Q is equals to 1. If P equals to Q, remember that condition. And is 0 if P is not equals to Q. Then we have for A now that we already stated that condition, it's simple for us to be able to solve. For now, we have what? What's the solution now?
We have chronicle PQAQRS equals to AQRS. A raised power QR then S. Since chronicle PQ is 1.
Remember what I did? So I assume P equals to Q now. So from the question, what do they give us?
We're given chronicle PQ, AQR.
AQR. So if they are the same, definitely P will be equals to Q.
Q, exactly.
But if they are not the same, it will be 0, which we don't need. And you just get your mark. B, you said chronicle P, Q, dot chronicle, no, consider dot in Bell.
There was no dot there.
Yes. Equals to, you just put PR. That's all. Because P, the law that you stated of will help you. Are you getting it now?
There's a question like this came out in the past question. But
Eh?
instead a question like this came outside the past question, but they could not write the conical anyway. They now put integral there.
Okay.
They wrote that integral instead of conical.
It is well. So at least you have idea of what they are saying.
Yes,
If
sir.
you look at this one, it says show that the SQP over the SQ equals to chronicle PQ. So if solution now,
P equals to Q.
we have to show that this is equals to this.
Yes, sir.
You start from the law. If P equals to Q, then the SQ, the SP over the SQ is equals to 1. Since SP is equals to SQ. But if P is not equals to Q, then the SP over the SQ is equals to 0. Since SP and SQ are
independent.
Then the SP over the SQ is equals to delta PQ. That's what they asked us to do. So all you need to do is just a simple analysis, what I did now. You can see it's not that difficult. All you just need is just to know how to define, how to use your fundamental law. If it's more than one, the same thing happen. So, okay. So I think on Tensor, those definitions will help us here to be able to solve so many problems. But the one of the Christopher law, you said you know it. You said what?
I wasn't the one talking, sir.
Okay. Okay. So if you look at this, let me just chip in something here so that by the time you are solving it on your own, you will have a better understanding about it. Christopher law is the same thing, or it's a Christopher symbol. Let me put it a symbol. So the symbols are so when you have PQ, R, it's the same thing as 1/2, open the bracket, the G is PR over the SQ plus the G QR over the SP minus DG PGQ over the SR. So look at the symbols. Look at the way we pair them. PR, then QR, minus then PQ. Then each of them divided by each of the coordinates. Then, in case you have this SPQ is the same thing as GSR into PQ, R. Accord the Christopher symbol of the first and second kind respectively. Other symbol used instead of Christopher symbol is they use gamma also to define some activities. They can give you a question of this nature and ask you to define them. For example, if you are given JK, M bar, excuse me. So it's the same thing as PQ, R. We can define it the SP all over the X bar J, the SQ all over the S bar K, the XR over the S bar M. Are you getting it? Plus
Yes,
G of PQ into the X bar Q P over the X bar M, the square S Q over the X bar J, the X bar K. So we have so many of definitions in different form that can lead to that people have worked on and that will also be useful in the future. The last but not the least on this aspect is this. So it's the same thing as when you have the X bar N over the SS and the SP over the S bar J over plus so these are the definitions that law of transformation of Christopher symbol show. And they are not tensor unless the second term of the right are 0. So all these things has to be careful and also stated in what we are solving. Any question?
No, sir.
Okay. Wow. So you mentioned something earlier. What are you trying to, you are saying?
I was talking about parameterization actually the other time.
Okay. What about it? Let's look at it.
Like some of it I get some of it where we have x squared, but when it now has to do with the cos and the sines, where we have to parameterize in terms of, I don't know, like how do we like just determine that? See that we just know that okay, we're supposed to use cos here, we're supposed to use sine here.
No, the definition, I gave you the definition from onset. If you look at it, let me see whether I can still locate the note here. That was where we started the definition. Now, remember, okay, if you look at this, what does this look like? This particular one
This shape.
is the equation of circle.
Okay, so okay, yes, sir.
The circle says x squared plus y squared equals to r squared. So you yourself can use that memory. When you are given cylinder, you have to convert it. But this one, do you know that you can still make use of it by saying x squared equals to 4 minus y squared. That is, x will now be square root of 4 minus y squared. You can use this one to solve the problem. Are you getting the point?
Yes, sir.
Hello?
Yes, sir, yes, sir, yes, I'm with you, sir.
You can use this to get it. But all you need to do is look at this one. How do I know? Let's go to the equation, the problem. Look at this. This problem is talking about XY plane. We are just trying to verify here. That is why we don't lay more emphasis on that. And you already been given the closed region. You have the closed curve of a region banded with this. So these are the areas. Then try to study some of those questions that we solve and the one in the notes in the textbook, and you will discover that some of those questions, they are very pretty simple. All you need to do is just look at it in pictorial form like this one. That is, if I have a close coordinate, if I start from here to this particular one, I know it's my y equals to x in this case. But at the end of the day, when y is equals to x squared, what happened at what point is there? At what point here? At this is the point where x is equals to, this is s equals to, y equals to x squared. Started from x to s squared. Then from here, you'll be able to trace it. And you have the equation also. Then there is a particular one that we did that I think I also define. I look at this diagram now. What is the diagram is talking about? If you read the question, from the knowledge of the question, would lead us to how to represent some of the diagram that we needed to do the parameterization. The question will determine, not that you just draw anything. You understand my point?
Yes, sir, yes, sir.
The question will determine it.
So once I see a question like this, the first thing I should just picture the diagram. Because if I can picture the diagram, then I should be able to.
Yes.
Okay, sir.
That is it. How you do that. So that's how